Welcome to the CIS 101 video, where we'll learn how to modify just half of our picture. But I want to start this video with two important concepts. First, if you notice, green has changed to this purple color in my function. And hopefully you've seen this function before in previous videos. Now, this is okay, but what that means is that green is something that's built in. And if I type green down here, you can see that it's a color is automatically assigned to a color. So we have a bunch of built-in colors like green, red, blue, and so on. Now, it's perfectly okay to assign green to be something different like I did right here. So instead of being the color green, it's going to be a number that represents how much green is in this pixel multiplied by 0.7. So then then we can't go back and use our green anymore though, because we changed what green is. Now Python will run just fine, but it probably isn't a good idea to change some of the built-in things that Python has given us, and that's why I've been using G or some other name instead of green or blue or red, because green, blue, and red are already pointing to a built-in color. Now I've gone ahead and loaded my Greek ruins file off of the disk so I can call it on this function. And we'll go ahead and call reduce green and pass in our ruins. And we can explore our ruins and see that we've made it look a little more purple because the green is smaller and the red and blue channels get magnified. Now, what I really want to show you is we use the name G inside of this function. Can we use G down here now? And you notice G is not defined. Now, I defined a function, I used the name G, I even called the function to run it. How come G is not defined? And that is because of scope. The scope of a variable is inside the block it's declared in, or inside of the function it's declared in. So since I defined G inside of this function, I can only use it inside of this function. Now the reason for this is programs can get very big. And in fact, we can have lots of people working on the same program. So if one person decides to use the variable g for his function, another person might use that same name, g, for his function. And unless they're working really closely together, they won't know it. And that might cause bugs because one person thinks g is one thing and another person thinks g is something else. So for that reason, we limit the scope of our variables to just the function they are declared in. Now, names that we do in the black part down here are called global variables, meaning we can use them anywhere in our program. We can also declare global variables up here just outside of any function. Now, since I've removed the indentation, that means I'm no longer inside of this function. I can go ahead and create a name and set it equal to what I want. And when I click load program, you can see I can use that name down here. But the only, sorry, it's file name. I can use file name down here. Now, the only reason why I can use this in the black part is because I declared it outside of any function, meaning that its scope is global. Now, our goal in this video is to learn how to operate on just half of our picture. We don't want to reduce the green in every pixel of our picture. We only want to reduce the green in half of it. So to demonstrate this, I've created a function called print half the numbers. That's my goal. I only want to print half of the numbers in this list. And I have this loop for num in numbers, and I print the number. Now, as you can see, when I ran that function, it printed all of the numbers in the list. But I only want to print half of them. How do I do that? Now, the first thing that we have to learn to only print half of them is this new built-in function that's part of Python, and that's called range. And I could just put range 5, and range is like a list generator. It generates us a list of numbers. So you could see if I did range 5, it generated us a list starting at 0 going up to but not including 5. Now we can also call range with two numbers. Let's say 5 and 10. And you can see I start at 5 and I go up to but not including 10. Now be really careful here because we do not include this number in range. And so that's a good test question to see if you remember that we go up to but not including our ending number. So this is where we start and this is where we end. Now, if we want to do something a little more advanced, we can start at 5, go to 20, and just do every third number. So you can see that we go 5, 8, 11, 14, 17, and then we don't do 20 because we go up to but not including 20. So the most common way that we'll use range will be either this way or this way. I want to show you how we can use range to only print half of these numbers. As you can see, I created range that goes from 0 to 5. If you notice, there are 10 numbers inside of this list up here. So I'm going to create a range that starts at 0 and goes to 5. And then I'm going to say for each index in my range, print the number at that location. So 0 will be first and we'll print 10. Then we'll do 1 and that will be the second spot, then 2, then 3, then 4. And we won't include 5 in our list. So this could probably use a better visual explanation of what's going on. Now you can see that I created a numbers list or a list with the name of numbers, and this is how it looks like. Now if you notice, the first number 10 is stored in the first box, the last number is stored in the last box. But each box has an index, and we always start with 0 and count up by 1. So every list or an array has an index. So 0, 1, 2, 3, 4, 5, all the way up to 9. Now I create a second list by using range. So my range is this list, and it has the numbers 0 through 4 inside of it. And now, instead of looping through the numbers array or list, I'm going to loop through my range. So for each index or number in the range, so I'm going to go for each one, then I'm going to print out the numbers at that position. So let's see how this works. The first number in the range is 0, so we're going to grab that out and put it in our index box. Then we're going to do this line of code. So we're going to look up index, find that it's 0. We're going to find the box with the index of 0, and we're going to print out 10 to the screen. Now we're going to move on to the next number, 1. And 1 is now going to become our index. And when we print our numbers based on that index, we're going to look up index, see that it's 1, and that's going to tell us to print 20. So you can see the next number is 2. 2 gets named index, and then we use 2 to tell us which box to print. Same for the next one. And the last one. So that's why we only print out 10, 20, 30, 40, and 50, and we didn't do anything with the rest of the numbers. Now the reason why that happened is my range only goes from 0 through 4, and we use these numbers to tell us which boxes in this list to print out. And that's how I'm able to only do something on half of my numbers. Now we can simplify this a little bit by taking our range and putting it here instead of naming it and then using the name there. So what if I only want to reduce green in half of my pixels? So instead of going for each pixel in my get pixels, what I can do instead is create an array of pixels and make sure I give it a name. So now I have all of the pixels that are in the picture, and now I can say for each index in, and we can use our range function, and we'll start at 0, and we'll go to the length of our pixels. Now in this case, now len is a function that returns how many items are in this list. So this will tell us how many pixels are in this list. So this would work, and then instead of doing pixel down here, we'll do pixels, and we'll do our index, just like we did index down here. And we'll also have to change this one as well. Now, let's just pause a little bit and look at our syntax. If you notice, sometimes we have parentheses that are rounded, and other times we have square brackets. So whenever we're using square brackets, like right here and right here, and we also use square brackets down here, that means we're dealing with a list or an array. Square brackets are to index into an array. So remember, an array has lots of values. Which one do we want? Well, the one that has this index. So those are square brackets. Parentheses, on the other hand, are whenever we want to call a function. So getPixels is a function, range is a function, length is a function, setGreen and getGreen are all functions, and that's why they use parentheses. Now, if I were to stop here, if I were to just run this function, we'd still change every pixel because we're starting at 0 and we're going to the length of our number of pixels. So just a little bit more information on this length function. We'll go ahead and create a list called numbers, and we'll put 7 or 3 elements in it. And if we do length of our numbers, it tells us that the length is 3. But if we use that in range, so we'll start at 0 and go to the length of my numbers array, you'll see that I'll get a list with 0, 1, and 2. That's because the index of this one is 0, 1, and 2. So that will work perfectly if we want to go through every pixel. But I only want to go through the first half. So what I'll do is I'll just divide that by half. Now just a little bit more detail. If I have a numbers array that has these numbers in it, and I want to go through half, I did range from 0 to 5, which created me a list of indexes from 0 to 4. Now, if I do range from 0 to the length of my numbers, notice I use the indexes 0 through 9. But if I do a range from 0 to the length of my numbers divided by 2, I get the numbers from 0 to 4. Now, why not just put 5 here? Well, we might not know how many numbers are inside of our array. And in fact, each picture that will have a different dimension and a different number of pixels in it. So we have no idea how many pixels might be in this list or array of pixels. So we use the length to be able to figure out how many pixels are inside of it, and then we just divide it by 2, and that tells us where to stop. I loaded my ruins back off of the disk, and then I called that function, passing it in and exploring it, and as you can see, I reduced the green, but only in the top half of the picture. Now, remember I told you when we say get pixels, it starts at the top, and just like a typewriter would go, it gets all of the pixels across the first row, then it moves to the beginning of the second row, gets all of those pixels, and so on. So it kind of works its way down this way, and then we got all of the pixels, but we only reduced the green in the top and the first half of them. So that's why the top half of the picture is a little more purple than the bottom half.